In this video series, we are introducing to you the SWAN survey, which is one of the most recent efforts of the PHANGS collaboration. In this series, we will introduce to you both the data, but also the science that we can do with this data set. But first of all, what is SWAN and why do we need it? To answer this, let's quickly introduce to you star formation. Star formation is one of the most fundamental processes in our universe. It forges the elements that life on Earth depends on, but it is also important for the growth and evolution of entire galaxies. But how exactly star formation happens is still not fully understood. Over the years, we have found out that star formation is tightly linked to the evolution of molecular clouds which fuel star formation. In the schematic picture of the molecular cloud evolution, we have molecular clouds in which, if the conditions are right, even denser molecular gas is able to form. And this even denser molecular gas may collapse and then form future stars. And these stars, once they are born, the stellar feedback, ejecta or supernova, will not only bring back material into the interstellar medium, but also they're able to destroy or disrupt the cloud it was initially born in. So in this cycle, we can see that the molecular gas is the fuel for star formation. So if we want to understand star formation, we need to understand the molecular gas. Now, these clouds are actually not isolated, but rather we have large numbers of molecular gas, of molecular clouds that reside in galaxies. And recent studies have shown that if we have a look at the properties of the molecular clouds and also of the star formation, they seem to change depending on where the cloud is located within the galaxy. Star formation may differ in a spiral arm compared to the center of a galaxy. But how does this happen? How can those large-scale galaxy environments impact the small-scale star formation physics? This is the main question that we are trying to answer with the SWAN survey. And to understand this problem, there's two paths that we can consider. So first of all, we need to understand the physical conditions of the molecular clouds. And second, as you have seen from the schematic, we've so far ignored one important point in this evolutionary scheme, which is the denser molecular gas. But how do we access both of those points? We need observations of different molecules, because different molecular species are sensitive to different conditions in the interstellar medium. And this brings me directly to our observations. Surveying the Whirlpool Galaxy dark seconds with NOEMA, in short SWAN, is an ERAM large program that combines 200 hours of NOEMA observations with 70 hours of ERAM 30-meter observations. And what makes this survey so important are 3 points. First, we have a high resolution of about 100 parsecs, so we are able to reach the sizes of giant molecular clouds. Second, we have a high sensitivity, so we're able to map comparably faint molecules such as diazenylium. And third, we have a very large field of view of 5 × 7 kiloparsec, which means at a resolution of roughly the size of giant molecular clouds, we're able to probe different molecular species in multiple environments at once. And the observations include emission of CO isotopologues, of dense gas tracers, of molecules sensitive to photodissociation regions or to shocks. And you will hear more about all these molecules in all of the upcoming videos. And as I've mentioned, one of the key points of this dataset is that we have all these multiple environments at once. So let's also quickly introduce to you what these environments are. Let me show you the Whirlpool Galaxy, also known as M51. And this galaxy is not only known for its beautiful spiral arms, but it also has a lot more to offer. This galaxy has quite a high surface brightness, which allows us to really observe fainter molecules. Then if we start from outside to inside, we have the dwarf companion galaxy, which impacts the kinematics of the entire disk, even in the central region. Then we have the 2 spiral arms, which come together in the center of the galaxy, forming a pseudo-molecular ring. And within the molecular ring, we have a nuclear bar. And in the very center of the galaxy, we have an AGN and an outflow. All in all, M51 is a really good target to study the impact of the galactic environment onto star formation with our SWAN dataset. This is the motivation behind the dataset and why it is so crucial to have a survey like the SWAN survey. So stay tuned for more videos about the SWAN survey.